What is a two-sample t-test? When do we perform this hypothesis test? And how to perform a two-sample t-test? In this video, we will try to understand that. Let's say there are two distinct species of rabbits. We want to know whether the mean weights of the two species of rabbits are different. Now, there are thousands of rabbits in each species. It is time consuming and expensive to collect the weights of each rabbit in each species and then compare the mean weights of each species of rabbits. So, instead, we can collect random samples from two distinct species of rabbits and take the mean weight of each species of rabbit. Let's say for the first species of rabbits, we have collected a sample of 15 rabbits and got the mean weight mu1 to be 800 gram. And for the second species of rabbits, we have collected a random sample of 20 rabbits and got the mean weight to be mu2 is equal to 850 gram. Now, these two mean weights are different, but is the difference statistically significant? Can we say from this difference that the mean weights of the two distinct species of rabbits are different? To know that, we need to perform a two-sample t-test. Please note that for a two-sample t-test, the following assumptions should be satisfied. The samples should be collected using the random sampling method. The observations in one sample should be independent of the observations in another sample. The data should be approximately normally distributed, and the variance of the two samples should be approximately the same. Let's assume the sample variance of the first sample is 15 and the sample variance of the second sample is 16. So, to summarize, these are the data that we have. For sample 1, mean weight is equal to mu1 is equal to 800 gram, sample variance is equal to S1 is equal to 15 and the sample size is equal to N1 is equal to 15. And for sample 2, mean weight is equal to mu2 is equal to 850 gram, sample variance is equal to S2 is equal to 16 and the sample size is equal to N2 is equal to 20. Our null hypothesis in this case is that the mean weights of the two distinct species of rabbits are the same. In other words, mu1 is equal to mu2. And the alternative hypothesis is that the mean weights of the two distinct species of rabbits are not the same. In other words, mu1 is not equal to mu2. Let's also assume that our significance level alpha is equal to 0.05. Now, we need to calculate the t-score for the hypothesis test. The t-score for a two-sample t-test can be calculated using the following formula. T is equal to x1 bar minus x2 bar divided by sp into root over 1 by n1 plus 1 by n2. Here, x1 bar is the mean of the first sample and x2 bar is the mean of the second sample. Sp is the pooled standard deviation and that is equal to root over n1 minus 1 into s1 square plus n2 minus 1 into s2 square divided by n1 plus n2 minus 2. Please note that n1 and n2 are the sample size of the first and the second sample respectively. In our case, x1 bar is equal to 800, x2 bar is equal to 850, n1 is equal to 15, n2 is equal to 20, s1 is equal to 15 and s2 is equal to 16. Please note that s1 and s2 in our case are approximately the same. When s1 is more than 2 times s2 or s2 is more than 2 times s1, we cannot use the two-sample t-test. In that case, we need to use the Wales t-test. Let's calculate the pooled standard deviation. Sp in this case is equal to 15.58 after calculation. So, if we put all the values, we get the t-statistic to be minus 9.39. Now, for a two-sample t-test, the degrees of freedom is equal to n1 plus n2 minus 2. In our case, the degrees of freedom is equal to 15 plus 20 minus 2, that is 33. We know that t-statistics follow t-distribution, and the shape of the graph of t-distribution depends on the degrees of freedom. In other words, the critical value depends on the significance level alpha and the degrees of freedom. Here is the t-table. We have the significance level alpha is equal to 0.05 and the degrees of freedom is equal to 33. So, we will first look at row 33 and column of acceptance region 0.95 and rejection region 0.05. We know that if the significance level is 0.05, then the area of the acceptance region is 0.95 and the area of the rejection region is 0.05. So, as per the t-table, the critical value is 2.035. Please note that in our case, the t-score is minus 9.39. We perform a two-tailed hypothesis test and the absolute value of the t-score is more than the critical value, which is 2.035 in our case. So, the t-score falls within the critical region. Hence, we will reject the null hypothesis. So, as per our two-sample t-test, the mean weights of two distinct species of rabbits are significantly different. I hope this helps. Interested viewers who want to know more, please visit the website of the Security Buddy or refer to the playlist Statistics for Machine Learning. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.